Welcome back to Dansplain. I'm Edward.
I'm Lily.
And today we're going deep on artificial intelligence.
Oh, yeah, AI.
It's been creeping into our lives for years, but lately it feels like it's everywhere. We're using it to write emails, generate images, even drive our cars.
It's true. AI is rapidly changing the world around us.
Yeah.
And to understand where it's going, we need to understand where it came from.
Exactly. So today we're taking you on a journey through the history of AI.
Okay.
From its humble beginnings to the mind-blowing possibilities of the future.
We'll unpack the key concepts, introduce you to some of the brilliant minds who shaped the field,
Right.
and explore how AI evolved from a science fiction fantasy to a technological reality.
Okay, let's rewind all the way back to the 1940s and 50s.
Okay.
Picture this. World War II is raging, and a brilliant mathematician named Alan Turing is hard at work cracking the Enigma code.
Alan Turing, a true visionary.
Yeah.
Not only was he a code-breaking genius, but he also laid the groundwork for the field of artificial intelligence.
And get this, even before computers were a thing, Turing was already asking the big question, can machines think?
He proposed that machines could learn and solve problems just like humans by processing information in a specific way.
Okay.
To test this, he devised the famous Turing test.
The Turing test.
A way to determine if a machine could exhibit intelligent behavior indistinguishable from a human.
Imagine having a text-based conversation with someone online.
Right.
And not being able to tell if it's a human or a machine.
Yeah.
That's the essence of the Turing test.
That's it.
It's still a benchmark in AI today.
Absolutely. Turing's work was groundbreaking, and it set the stage for the development of the field.
But AI isn't just about thinking machines.
Right.
It's also about how machines interact with the world around them.
Right. And that's where Norbert Wiener and the field of cybernetics comes in.
Cybernetics.
He was fascinated by feedback loops, systems that can learn and adapt based on input from their environment.
Like a thermostat that adjusts the temperature based on the room's reading, right?
Exactly. Wiener's work on feedback systems was crucial for developing AI that could interact with and learn from its surroundings.
So we've got Turing planting the seeds of machine intelligence, and Wiener exploring how machines can adapt and learn. What happens next in this AI origin story?
Well, in the summer of 1956, a group of brilliant minds gathered at Dartmouth College for what's now considered the birthplace of artificial intelligence as a field.
The Dartmouth Workshop.
Yeah.
Kind of like a summer camp for AI pioneers.
Yeah, exactly. It was at this workshop that the term artificial intelligence was coined, and the researchers laid out an ambitious agenda for the field. They believed that machines could be made to simulate any aspect of human intelligence.
That's a pretty bold statement.
Yeah.
So they set the stage, and then what? Did they start building super intelligent robots right away?
Not quite robots, but they did create some groundbreaking programs.
Yeah.
One early example was the Logic Theorist, developed in 1956. This program could actually prove mathematical theorems.
Hold on, a computer proving mathematical theorems in the 1950s. That's seriously impressive.
It was a major step forward. It showed that machines could engage in complex reasoning tasks, opening up a world of possibilities.
Yeah.
Then, in 1966, Joseph Weizenbaum created ELIZA, a chatbot that could simulate human conversation.
A chatbot back then.
Yeah.
That seems way ahead of its time. What was it like interacting with ELIZA?
Well, picture a very simple text-based conversation.
Yeah.
You could type in something like, I'm feeling sad.
Right.
And ELIZA might respond with, why are you feeling sad?
So kind of like an early version of Siri or Alexa,
Yeah.
but much more basic.
Exactly. But even with its limitations, ELIZA had a profound impact.
Yeah.
People were amazed by its ability to seemingly understand and respond to them, even though it was just following a set of rules.
It sounds like those early days were filled with optimism and a sense of wonder about what AI could achieve.
There is definitely a lot of excitement, but the path of AI hasn't always been smooth. In the 1970s, the field encountered its first major setback.
The infamous AI winter. What happened?
Well, the hype around AI had gotten ahead of reality. Computers at the time simply couldn't handle the complex tasks that researchers had envisioned.
So it was a case of overpromising and underdelivering.
Exactly. And when funding dried up and research slowed down, it felt like AI had hit a wall. But the story doesn't end there. AI would eventually thaw out and enter a new spring thanks to a shift in approach.
Okay, this is getting really interesting. We need to take a quick pause. When we come back, we'll explore how AI emerged from the winter and sparked a new era of innovation and progress. Stay tuned.
Welcome back to Dansplain.
All right, so before the break, we were talking about how AI hit a bit of a roadblock in the 70s with the AI winter. It sounds like those early computers just couldn't keep up with the grand visions of the researchers.
Yeah.
But how did AI come back from that?
Well, the field shifted its focus. Instead of trying to create general-purpose AI that could do everything, researchers started developing expert systems.
Expert systems, what are those?
Think of them as specialized programs designed to solve specific problems in a particular field, like diagnosing a disease or configuring a complex piece of equipment.
So instead of trying to build a super intelligent machine, they focused on creating tools that could assist human experts.
Exactly. One famous example is MYCIN, developed in the 1970s to diagnose bacterial infections. MYCIN could analyze patient data and recommend treatments just like a human doctor.
That's pretty impressive. Were these expert systems actually used in the real world?
Oh, absolutely. They proved to be quite useful in various fields, from medicine to finance to engineering. But they had their limitations.
What kind of limitations?
Well, they were very rigid. Expert systems were great at what they were trained to do, but they couldn't adapt to new situations or learn from new data very easily.
So they were like brilliant specialists, but lacked the flexibility to handle anything outside their narrow area of expertise.
Exactly. And that ultimately led to another period of disillusionment in the late 1980s, another AI winter, so to speak. But this time, the seeds of a more powerful and adaptable approach were already being sown.
Okay, you've got me on the edge of my seat. What was this new approach that would revive the field of AI?
It was the rise of machine learning, or ML for short. This is where things start to get really interesting.
I've heard a lot about machine learning, but to be honest, it still sounds a bit like science fiction to me. What exactly does it mean for a machine to learn?
It's all about enabling computers to learn from data without being explicitly programmed for every single possibility. Instead of giving the computer a detailed set of instructions, we feed it tons of data and let it figure out the patterns on its own.
So it's like showing a computer a million pictures of cats and dogs and letting it learn to tell the difference between them.
Exactly. That's a great example. With traditional programming, you'd have to write code to describe all the features that distinguish a cat from a dog. But with machine learning, the computer can learn these distinctions by analyzing thousands or even millions of examples.
That sounds way more efficient. But how does a computer actually learn from this data? What's going on under the hood?
There are lots of different techniques, but one early and influential method is called decision trees.
Decision trees. I'm picturing a computer sitting under a tree pondering the meaning of life.
Well, not quite like that. Imagine a flowchart with a series of yes-no questions. The computer uses the data to build this tree learning to make decisions based on the answers to these questions.
Okay, so it's like a choose-your-own-adventure book for computers.
You could say that. Let's go back to your cat and dog example. The decision tree might start with a question like, does the animal have pointy ears? If the answer is yes, the computer might then ask, does it have whiskers? By answering a series of these questions, the computer can eventually classify the animal as a cat or a dog.
That makes sense. Are there any other learning methods that are particularly important?
Another powerful technique is called reinforcement learning. This is where a computer learns through trial and error by being rewarded for good decisions and penalized for bad ones.
It's like training a dog with treats, right?
Exactly. A classic example is TD Gammon, a program developed in the early 1990s that learned to play backgammon at a championship level.
Wait, a computer playing backgammon like a pro? How did that work?
Well, TD Gammon played millions of games against itself, receiving rewards for winning and penalties for losing. Through this process, it learned the best strategies and tactics for winning the game.
That's incredible. So it sounds like machine learning was a real game changer for the field of AI. When did this approach start to make its way into our everyday lives?
Well, it was a gradual process, but by the late 1990s and early 2000s, machine learning was popping up everywhere. Companies like IBM were using it for things like spell checkers, fraud detection, and even personalized product recommendations.
So AI was quietly working its magic behind the scenes, even if we weren't always aware of it.
That's right. And then in the early 2010s, a new breakthrough emerged that would truly revolutionize the field.
Okay, I'm sensing another pivotal moment in the AI saga here.
Yeah.
What was this breakthrough?
It was the advent of deep learning, a powerful type of machine learning that uses artificial neural networks.
Neural networks. Now we're really getting into sci-fi territory. Are we talking about robot brains here?
Not robot brains exactly, but neural networks are indeed inspired by the structure and function of our own brains.
So how do they work?
Imagine a vast network of interconnected nodes, kind of like neurons in your brain. Each node performs a simple calculation, and the network learns by adjusting the connections between these nodes.
Okay, so it's mimicking the way our brains process information. But what makes deep learning so special?
One key factor is the sheer size and complexity of these neural networks. They can have millions or even billions of nodes, allowing them to learn incredibly complex patterns.
That's mind-boggling. And this is all thanks to more powerful computers.
Exactly. Advances in computing power, especially with the development of GPUs, have made it possible to train these massive neural networks on enormous amounts of data.
So more data plus more computing power equals deep learning magic.
You got it. And the results have been truly remarkable.
All right, give us some examples. How has deep learning been used to solve real-world problems?
One striking example is in image recognition. In 2012, a deep learning program called AlexNet stunned the world by winning the ImageNet competition, a massive image classification challenge.
Wait, so a computer beat humans at recognizing images?
Not just beat them, it crushed the competition. AlexNet was significantly more accurate than any previous image recognition system. It was a turning point that ignited a wave of research and development in deep learning.
That's incredible. What other areas has deep learning had a big impact on?
Well, another area is game playing. In 2016, Google DeepMind's AlphaGo program defeated a world champion Go player.
Go, what's that?
Go is an ancient board game that's considered far more complex than chess. For a long time, it was thought that a computer could never beat a human at Go.
So this AlphaGo victory was a huge deal.
It was a landmark achievement. It showed just how powerful deep learning could be in tackling complex problems that require intuition and strategic thinking.
Wow, it sounds like deep learning is changing the game in a lot of different fields. But what about more creative pursuits? Can AI be artistic?
Absolutely. Programs like DALL-E, developed by OpenAI, can create amazing works of art from simple text descriptions.
Wait, so you can just type in something like a cat wearing a spacesuit riding a unicorn on Mars, and DALL-E will paint it.
That's pretty much it. It's revolutionizing the art world and blurring the lines between human and machine creativity.
That's both exciting and a little bit scary.
Yeah.
What about the real world beyond games and art? Is deep learning being used to solve practical problems in fields like medicine or engineering?
It's happening all around us. Deep learning is being used to develop new drugs, diagnose diseases earlier, and even personalize treatments based on a patient's individual genetic makeup.
Wow, so AI is literally saving lives now. But what about the physical world? Are we going to see robots walking around doing our chores anytime soon?
Well, that future might be closer than you think. Companies like Tesla and Boston Dynamics are developing increasingly sophisticated robots that can perform a wide range of tasks.
Okay, so robots are becoming more capable, but are they still just following pre-programmed instructions, or can they actually learn and adapt?
That's where AI comes in. These robots are being powered by machine learning algorithms that allow them to learn from their experiences and improve over time.
So we could have robots cleaning our houses, cooking our meals, and maybe even composing symphonies.
Exactly. And they're becoming increasingly intelligent and adaptable thanks to advances in machine learning and natural language processing. Imagine having an AI agent that could proactively anticipate your needs and take care of tasks before you even ask.
This is all incredibly fascinating, but I have to admit it's a bit overwhelming to think about all the implications of this technology. Where is AI headed? What does the future hold for us?
That's a big question, and one that we could probably spend a whole series exploring. But for now, we've covered a lot of ground, from the birth of AI to the rise of deep learning and intelligent agents. Let's take a quick break to absorb all this amazing information, and when we come back, we'll delve into some of the mind-bending possibilities that AI holds for the future. Stay tuned.
Welcome back to Dansplain. We've journeyed from the dawn of AI through those chilly AI winters all the way to the rise of these incredible deep learning machines.
It's been quite a ride, and as we look ahead, the possibilities seem almost limitless. But with such powerful technology comes this great responsibility.
Absolutely. AI is already reshaping our world in profound ways, from how we work to how we create art, even to how we diagnose and treat diseases.
Yeah.
But it also raises some big questions about the future.
Right. Questions about jobs, privacy, the very nature of intelligence, and even what it means to be human. These are things we need to be talking about as AI continues to evolve.
Okay, so let's dive into some of these big questions. One that I hear a lot about is the impact of AI on jobs. Are robots going to take all our jobs? Is that the future we're headed towards?
It's a valid concern. As machines become more capable, they could potentially automate many tasks currently done by humans. but it's not necessarily a doom and gloom scenario.
So you're saying it's not as simple as robots versus humans?
Exactly. While some jobs will inevitably be automated, AI also has the potential to create new jobs and opportunities. We'll need people to design, build, maintain, and even train these AI systems.
That makes sense. So it's not just about replacing jobs, it's about transforming the workforce.
Right. And AI could also augment our existing jobs, making us more efficient and productive. Imagine having an AI assistant that can handle all the tedious tasks, freeing up humans to focus on more creative and strategic work.
That sounds pretty appealing. But what about the potential downsides? What are some of the ethical challenges we need to consider as AI becomes more powerful?
Well, one concern is the potential for bias. AI systems are trained on data. And if that data reflects existing biases in society, the AI can perpetuate and even amplify those biases.
Can you give us a real-world example of that?
Imagine an AI system used to screen job applicants. If the data it's trained on reflects existing gender or racial biases in hiring practices, the AI might unfairly discriminate against certain groups of people, even if that's not the intention.
That's a serious issue. So we need to be very careful about the data we use to train AI systems and ensure it's fair and representative.
Absolutely. We need to be mindful of how we design and deploy these systems to avoid unintended consequences.
Okay, bias is a big one. What about privacy? AI relies heavily on data collection. So how do we ensure that our personal information is protected?
That's another critical question. Think about all the data that companies like Google and Facebook collect about us. They use this data to personalize our online experiences, but it also raises concerns about how this information is being used and who has access to it.
It seems like we're constantly giving up more and more of our privacy in the name of convenience or personalization. It's a tricky balance.
It is. And as AI becomes more sophisticated, we need to have open and honest conversations about data privacy and establish clear guidelines for how our information is collected, used, and protected.
All right, we've talked about jobs, bias, and privacy. But what about the really big questions, the philosophical ones? Could AI ever become conscious? Could it pose a threat to humanity? I know these questions sound like something out of a science fiction movie, but are they really worth considering?
They are definitely worth considering. We're still a long way from creating AI that's truly sentient or self-aware. But as AI continues to evolve, we need to think about the potential implications and ensure we're developing this technology responsibly.
It's definitely a lot to think about. So where do you think AI is headed in the next few years? What are some of the most exciting developments on the horizon?
Well, one area that's generating a lot of buzz is the development of brain-computer interfaces, or BCIs. This is technology that connects our brains directly to computers, allowing for two-way communication between the human brain and machines.
Wait, like something straight out of the Matrix.
Kind of. Companies like Neuralink, founded by Elon Musk, are working on developing BCIs that could potentially allow us to control computers with our thoughts, treat neurological disorders, and even enhance our cognitive abilities.
That sounds both incredibly exciting and a little bit terrifying.
It definitely has the potential to be both. But it's an area of research that holds immense promise for medicine communication and even our understanding of consciousness itself.
So the future of AI is full of incredible possibilities, but it also presents us with some profound challenges. What's the one thing you'd want our listeners to take away from this deep dive into the world of AI?
I think the most important thing is to stay informed, engaged, and curious. AI is a powerful tool that can be used for good or for ill. It's up to us to ensure that it's developed and deployed in a way that benefits all of humanity.
Well said. This has been an incredible journey through the world of AI. We've covered a lot of ground today, but there's so much more to explore.
If you're eager to delve deeper into this fascinating field, we encourage you to visit our website, www.dansplain.xyz.
That's right. You'll find tons of articles, videos, and links to the latest AI research and developments. And be sure to check out our sponsors who are helping to make this show possible. They've got some amazing AI-powered products and services that you won't want to miss.
Thanks for joining us on this deep dive into AI. Until next time, keep exploring, keep questioning, and keep learning.
And keep on dansplaining.